Hi, I'm Finn Boetius, Product Marketing Engineer at Nordic Semiconductor. Here I have the nRF5340 Audio Development Kit, made for developing Bluetooth LE audio products. Watch this video to the end and learn everything you need to know about it. If you need to get familiar with the LE audio basics like broadcast audio, audio sharing and isochronous channels, we've made a page for you at nordicsemi.com/LE-audio. Together with the new use cases, LE audio allows for better audio quality and significantly lower power consumption. Let's start by looking at different ways to use the audio decay. If you want to develop an LE audio product, you likely have one of those use cases in mind. Devices can have multiple roles and therefore names in the specification. They can be an initiator, an acceptor, client and server, central and peripheral. And this makes a lot of sense to have specificity. But to not overcomplicate things here, we'll just use an audio source for a device that sends out a stream and an audio sink for a receiving device.
Our first device is a Bluetooth LE audio broadcaster or audio source device. We want to transmit audio streams to other devices. The kit can be configured to connect to a PC via USB or simply get a line-in signal to transmit an audio stream. We can broadcast or directly connect to one or more audio sync devices like headphones or speakers. The next use case is TWS, Truly Wireless Stereo. The kit functions as an earbud in this case. It can connect to an audio source as well as receive and send audio. For the whole setup you would need 3 kits, one to act as an audio source and then one each for the left and right earbud. Each earbud will receive its own monostream, so the result will be stereo audio over both ears. This is unlike Bluetooth Classic Audio, where one earbud receives the stereo stream, splits it up into 2 monostreams, and then retransmits one of those to the other earbud, together with timing information. With LE audio, both earbuds can have a separate connection to the audio source, saving energy, lowering latency, and using the same amount of power in both earbuds. The third setup is a simple broadcast receiver. Here we listen to a broadcast signal and play the transmitted audio. Last but not least, we have the headset use case, where the development kit receives a stereo stream. And as with the TWS example, we can send back audio from the microphone as well as play, pause, skip tracks and so on. Since the audio DSP on the board is specialized for a single speaker, you'll need to use an external DAC here.
Now that you know the use cases, let's look at the kit itself.
This here is the star of this show, our nRF5340 dual-core Bluetooth SoC. It supports Bluetooth LE, NFC and many other wireless protocols. What I'd like to highlight for Bluetooth LE audio is the audio PLL and the dual-core setup. This enables the SoC's great LE audio performance. The audio PLL supports an adjustable frequency with 3.3 ppm resolution in 2 frequency bands. It has very low jitter and is ideal for audio applications. The dual-core setup enables us to run the application and codec on the application core and handle communication on the network core. This is the Cirrus Logic CS47L63, a high-performance, low-power audio DSP for earbud headphones. It is optimized for direct connection to the headphone load. The power management and battery charging are handled by our NPN1100 power management IC. It is a super small, highly efficient PMIC for charging batteries and power delivery. Its power conversion efficiency goes up to 92% with a footprint of only 27 square millimeters. This includes all the passive components. You can even get as small as 23 square millimeters for size-constrained applications. At the side of the board, we have 2 3.5mm jacks to get your sound in and out of the audio decay. One jack is to be used as a headphone connector and the other one for line-in, making testing your application as easy as possible. If we look to the right of the board, we have buttons for play, pause, volume up, volume down, and 2 user programmable ones. In addition to that, we include 4 user programmable LEDs on the board. The top LED is an RGB LED that can be freely configured. For power measurement, we have current measurement pins located here. The different pins enable you to measure the part of the board that you are interested in. Here we have the SWF port for RF measurements. If we now look at the backside of the board, we see the battery connector. This is a USB-C connector and can be used for powering the board or programming and debugging. We've included a digital microphone that is located right here. This is an SD card holder if you need extra memory. And here we have RGB LEDs to light up the logo at the middle of the board in the colors of your choice.
As always, these kits are available through our distribution partners. You can find more technical details and documentation on our website. There you will also find hardware files, a getting started guide, and all development tools and software you need. If you have any questions or you need help, we have our excellent team of engineers on DevZone working to help you with technical support.